I just didn't find the oh my God, Jack, it's even relevant. This is relevant. Marriage, this is not becoming relevant. Are you still in trouble? It's a marriage, you can say they are. I'm definitely never in trouble. Oh, mark my words, Jack's here and had a divorced in the last week.
Anyone else coming in, or can I just stop?
Yeah, that's. I don't know if I want to get them to come down.
Then, yeah, I'll start at this point.
Actually, next week should be fine. The week after is like Lunar New Year celebration as well. So we might cancel that one
Just so we don't clash with someone.
if we have someone on that day, so we can move them to next week. I'll try and move them to next week so then we won't have to worry about speakers next week. I'll be back to that.
Should I switch because I don't want to keep.
That's not when I thought she was mad about me calling her the same slur on. Repeat this one.
Okay.
No recording, no recording.
Hello, everyone. Hope you're all doing well. So my name's Karthik, and I'm basically doing a talk on how to save a marriage mathematically. The key ideas will be modeling the dynamics of marital interaction, basically conversations between a husband and a wife, and we'll be using data sets and stuff from that to try to predict whether the couple is headed for a happy marriage or a divorce. So yeah, this is the most important part. Caution, I'm a math student. I haven't done any sort of clinical psychology, anything of that sort. So whatever you hear, whatever you listen to here, try to take it with a pinch of salt, If you feel any of it is useful for you, just try to do a bit more research before you actually try to implement it and stuff. So, and regarding the data itself, the data was collected in 1983 to 1987, a 4-year time span. So you should also use that as context for the results that are going to turn up. That's been, 38 years or 39 years at this point. So the data set is pretty old, but a lot of the results still seem pretty relevant. So yeah. Now, why are we trying to do this? So basically, typically, right, in the field of psychology, most of the mathematical models you'll encounter are basically just going to be statistical analysis. They'll basically just take two random variables, they'll put a linear regression, they'll put it through linear regression, they'll pull up whatever comes out of it, and yeah, that is the result that they'll use to inform you on how to deal with your psychological or social problems, which might be fair, but the key issue with things like marriages, right? Interactions between humans is not exactly linear. So linear regression doesn't serve the purpose of actually telling you why people interact the way they interact. So you would much rather have a bit more complexity because the system itself is highly nonlinear. So the entire, the next couple of slides, the entire thing is based on the work of G.M. Gorton. He is a marital psychologist, has some pretty good blogs and stuff as well. He was the first one who came up with the idea of using, dynamics and differential equations to model interactions in a marriage. And that was, enlarged and done more in depth by Cook and other authors in a 1995 paper. All of this, I've built the entire slides and everything from the textbook Mathematical Biology 1 by J.D. Murray. It's a very good textbook if any of you want to have a look and stuff. It has everything from this marital dynamic stuff to generation of patterns on the furs and skins of animals to a bunch of other interesting topics. It's a pretty good book. Now, why marital interaction dynamics? So basically, divorce rates are pretty high across the world. They are increasingly high in developed countries when this chapter was written, the divorce rates were already 50 to 67% over a 40-year span, right? So now here's where it starts getting surprising, right? Most people don't even survive for a 40-year-long marriage. So the fact that within a 40-year span, 50 to 67% of marriages are already headed for divorce is considered a pretty unideal situation. right? So intervention therapy is basically what is usually done. Intervention therapy is when, couples therapy seen in movies, series, all of that stuff, all the pop culture couples therapy, that's basically what intervention therapy is. It hasn't been uniformly successful. It helps some people, it doesn't help others. So any theory you could build on marriages in general is considered to be worthwhile pursuing. Now, here's the thing. All the variables being studied here are qualitative, right? Emotions themselves are qualitative. You cannot necessarily put numbers onto human emotions and how people interact and all of that stuff. So the general idea is our ultimate aim is to have a qualitative model, but a definite model. We basically want the conclusions we're getting out of this model to be definitive things that we can claim or speak about. So, yeah. And also, the data set will be used to test whatever we're getting out of the model itself, even though the model is built on the data set. The reason being, right, it's not necessarily sort of like statistics. Here, you're just using the model data, you're just using the data to inform how you'll construct your differential equations and stuff. But the data itself won't play a role in the differential equations. It might play a role in the parameters, and then you can estimate the parameters against what's there in the data. But yeah, you're not necessarily using the data within the model. So the model can be tested against the data again. Now, the next couple of slides, I guess for about 10 to 15 slides is basically just going to be me blabbering about all the background you'll need, all the psychological stuff, all the data, everything of that sort. So let's speak about the data set first. The data set is basically 73 couples who've been measured between 1983 and 1987. What is this data set I'm referring to? So the data set here is, right, it's basically a video interaction between the couple was measured for video recorded for 15 minutes, and then it was encoded using an observational coding system called the Rapid Couples Interaction Scoring System. The next couple of slides will explain what the Rapid Couples Interaction Scoring System is. For the sake of simplifying my typing out, I basically use the shortened version throughout the rest of the slides, RCISS. So what is the RCISS? So basically, as I said, you record a video interaction between the couple for 15 minutes, right? And within that, they were given a prompt for that 15 minutes. They were asked to speak about any specific problem they were facing in their marriage. It could be sex, it could be in-laws, it could be money, it could be any specific problem they were facing within their marriage. They had to speak about it for 15 minutes, right? And now, the important thing is what exactly is the RCISS system itself? We'll come back to the regulated and non-regulated part. So, yeah, on each conversational turn, right? Basically, a conversational turn was considered how long a person would speak before they stop and the other person speaks because it's a conversation. Within each conversational turn, the thing that was measured was how many positive things were said minus how many negative things were said, right? That basically gave a score for how much of a net positive the interaction between the couple was. Now, that basically gave them an idea of whether the couple were regulated, which means they had net positive interactions, more positive interactions than negative interactions, even while discussing a conflicted topic, or whether they were unregulated or non-regulated, wherein the couple had more negative interactions than positive interactions during the conversation, right? So yeah, that's basically what we're referring to when we say regulated and non-regulated. Regulated couples are ones who have more positive interactions, even when dealing with a conflicted topic. And the non-regulated ones sadly have more negative interactions or negative conversations when dealing with the topic in comparison to positive ones. Now, the other thing that was measured was also the humor and smiling that took place within the conversations. Why humor and smiling? An empirical observation within marital psychology and psychology in general, relationship psychology in general, is that when relationships suffer, the first thing to disappear is smiling and laughter. Now, smiling and laughter can be faked to some extent. So for the sake of this study, only Duchenne smiles were measured. Duchenne smile is basically this biological phenomenon wherein you actually smile with your entire face. You constrict your eyes and your lips have to move upwards. So yeah, if unless you're smiling that way, it wasn't considered a genuine positive effect within this coding system. And now, why do we care for the RCISS speaker codes or whatever? That RCISS score is basically what we'll be talking about for pretty much the rest of the talk, because that is basically what we're going to model with our differential equations, the difference equations, everything. That RCISS score is basically what we'll use to predict everything from whether the couple will be happy, whether the couple is headed for divorce, everything of that sort. Yeah. And now, you basically take the RCISS scores, you add them up, and you plot them. The slopes of these plots give you whether there is a net positive effect or a net negative effect of that 15-minute conversation over time. And here you start using a bit of the statistical methods of linear analysis and stuff. But yeah. As we were previously speaking, right, if both of them have a net positive score, then both the husband and the wife will tend to have a significantly positive slope when you do the linear regression and the graph is made. If both of them have significantly positive slopes, then they were regulated, right? And if at least one of the spouses did not have a significantly positive slope during the interaction, their RCISS scores weren't significantly positive, then they were considered unregulated. This classification, the name for this classification is the Gottman-Levinson variable. Gottman is the marital therapist. Levinson was a co-author on the paper, if I remember correctly. And now the key issue we start encountering here is it is difficult to predict whether the marriage will be formally dissolved because unsatisfactory marriages tend to last much longer than 4 years. Empirically itself, you can see they last much longer than 4 years. 4 years is too short a span for you to predict whether the marriage is headed for dissolution, but it still does give you enough insights into building a theory of marriages, right? And now we move on to marital typology. Marital typology is basically the one thing I disagree with in psychology itself is basically you're forced to put people into boxes. You have to draw boxes or circles and you have to put them into that. You're forced to type people as this is the specific type of person he is, or this is the specific type of person they are. The same thing is done for couples as well. And that is basically what marital typology is. The reason I sort of disagree with it is because it sort of becomes a one size fits all solution, which isn't necessarily true. But for the sake of this, we will still be going, for the sake of mathematical simplicity, we'll go with whatever they say. There are three types of positive marriages. The positive ones are validators, volatiles, and avoiders. And there are two types of unstable marriages, which are basically hostile and hostile detached. So let's take a look at what these ones are. So we'll first speak about the types of marriages and then we'll get back to the first paragraph. A volatile marriage is basically one which jumps between emotional extremes, right? It mixes a lot of positive effects with a lot of negative effects. And it tends to be quite romantic and passionate, but it risks dissolving into endless bickering, right? So it's because the relationship itself operates at such emotional extremes, it risks just becoming an endless conflict that just cannot be resolved through any manner whatsoever. And the validating marriage. The validating marriage is what you call the typical happy marriage in marital psychology, right? So it basically does everything in moderation. It mixes positive effects in moderation with negative effects in moderation. It is calm and intimate in comparison to the volatile marriage. But the risk here is there's a risk of the romance disappearing and it just becoming a close friendship. The third type of marriage, note here, all three are considered happy marriages in the sense of marriages that will last. These are not the marriages we think will end up in a divorce, although they may. These are the marriages you still consider to be archetypal happy marriages to some extent. The avoiding marriage is one where you mix a lot of positive effects with very little negative effects. The reason is because anyone who's in an avoiding marriage tends to avoid conflict and tends to try to replace that conflict with as much positive effect as possible. But the issue here is doing that ends up avoiding the pain of confrontation and conflict and risks emotional distance and loneliness. So how were we, putting people into these three types? The main method was, right, the rough constant that was invariant across all these three types of marriages is the ratio of positive effects to negative effects, which was 5. So think about it this way, right? In an average conversation over the span of the entire 15-minute conversation, both the husband and the wife, for every one negative thing they had to say about each other, they would end up saying about 5 positive things. That's the rough ratio we're talking about. So yeah, that is a very good empirical estimate for whether a marriage could be typed into one of the first three ones, the happy marriages, or yeah, whether it would end up in the other two ones. The other two ones I didn't necessarily write out because, yeah, they are. Let me just explain them quickly. So the other two are hostile and hostile detached. Hostile and hostile detached is when there is a clear-cut mismatch between the two people, and they tend to have conflicts. But the issue is the difference between hostile and hostile detached is the word detached, which basically means at least one of the spouses tends to not listen at all and doesn't care about the conflict that's happening. That leads to the detached state, which tends to be worse than just having a hostile marriage. So, yeah. Now, the next part. The goal of our mathematical model at the end of the day is, right, whatever was empirically observed, whatever was empirically observed, we're basically trying to break that and split that apart so that we can try to build a mathematical model for it, right? So the Gottman-Levinson variable, to recall, the Gottman-Levinson variable was basically the cumulative net positive effect minus the cumulative net negative effect, which basically gave you the total cumulative RCISS scores. And then you basically did the linear analysis. You got a slope. That slope was the Gottman-Levinson variable. You're splitting that apart into two things. So here's the thing, right? When a person's in a relationship, two things play a role. One is the individual dynamics of the person, and the other thing is how they're interacting with the other person in the relationship. So that's exactly how we're going to split up our RCISS scores. We're going to split it up into a function of interpersonal influence and parameters related to the individual's own dynamics. Why the influence is because whatever we're observing is basically a conflict between two people in a video interview, right? So in that situation, we basically want to find out how much influence each person has over the other, and that will help us better model the outcome of the scenario. What do we mean by an influence function? With influence function is basically the term we're trying to identify to help us understand how the couple is interacting with each other. The mathematical form is going to be across the horizontal and vertical axis. We're going to have the scores of both the people. Should I draw it out? Give me a moment, hopefully. Hmm. Okay. Hopefully this should be enough space. So basically what we're going to do is, right, we're going to look at a W term, which is for the wife, and an H term, which is for the husband, right? And we're basically going to write the scores at each specific time t. This should be a three-dimensional graph. And as we see how this thing travels within the 3D space, we start at some specific point and we see how it travels within the 3D space. The influence function will basically give us, the influence function will basically be the gradient. Yes, it will be the gradient of the curve that you have in three-dimensional space, right? That's the rough idea. For a more discrete approach, we tend to just do it as the average of the interaction scores between the husband and the wife, between the two spouses, across the turns of speech. So we're basically measuring their net positive interaction score. Now, so influence functions. Influence is basically how much one person is affecting the other during the span of their conversation. So here's the thing, right? Not everything you say to the other person will necessarily evoke an emotional response. Sometimes it might not reach the certain emotional threshold to make them react, right? It could be, the simplest example I can give is a bad joke won't necessarily make a person laugh unless it's extremely bad and the other person has a bad sense of humor to some extent. But yeah, the reason is because it has to meet a certain emotional threshold for the person to laugh, for the person to smile, or for the person to feel angry or sad, right? So to that end, we'll basically have a threshold which we'll put in depending on, the threshold can be modeled with increasing complexity using everything from marital satisfaction to stress levels, the temperament of the individuals, as well as cultural phenomenon. Yeah. To explain what this means is, right? So now the person who's speaking is basically modeled on the x-axis. The person who's listening is modeled on the y-axis. The person who's speaking, when they're modeled on the x-axis, how far they are along the x-axis in either direction is the net positive or negative score they have. Now, the impact on the wife is measured using the impact function, and that tells you the net positive or negative effect it is having on them during the conversation, right? Yeah, so the impact function will be modeled using a function. Usually you can pick between two functions, right? The standard ones in math bio are usually you either pick a two-slope function or you pick a sigmoidal function. The sigmoidal function serves better for the purposes we are looking at because we want to model it with sufficient complexity. And the sigmoidal function fits because it works on the threshold principle. Unless there's a certain threshold you reach, there won't be an activation within the sigmoidal function. So the same thing carries here. Let's start with what the actual mathematical model will be, right? We begin with a sequence of the RCISS scores. The RCISS scores is again just net positive interactions minus net negative interactions. The difference between them for that individual will basically be their score at time t. WT refers to the score of the wife at turn t, and HT refers to the score of the husband at time t, at turn t. And yeah, so in the process of modeling, we'll be using two things, right? One of them is emotional inertia. The emotional inertia is, basically refers to how quickly a person can come out of any specific emotion they're put into, right? It's basically the tendency to remain in the same state over a prolonged period of time. And the second parameter is their natural uninfluenced steady state, which basically refers to when the other person's score is at zero, how likely are you to, speak more positive than negative? That parameter will basically give you a score when the other person's score is zero. These two things together will allow us to model the individual dynamics of the person, right? So again, now the reason why we care about when it's a zero score is because the zero score won't have an effect on the other person in the conversation, right? So whatever comes after the zero score is just the individual dynamics. So that is the reason why we use the zero score of the other person to help us model the individual dynamics, basically to figure out both their emotional inertia as well as their uninfluenced steady state. What is the state they naturally gravitate towards when the other person isn't necessarily interacting with them? So yeah, we basically estimate both those parameters from a subset of the data, right? We basically subtract the uninfluenced effects. So basically, yeah, we take the net total interaction. Out of that, we subtract whatever we get from the data for these two, for the emotional inertia as well as the normal steady state, right? Uninfluenced steady state. And what we're left with is the influence function. Because when you remove the individual dynamics out of a relationship, all that's left is the interaction between the two people. And so the influence function reveals itself at that point. And from this, we get what we are what we truly care about, the influence steady state. The influence steady state is basically, we're looking for a sequence of two scores, one for the wife and one for the husband, that this sequence should gravitate towards. And hopefully, if that is a steady state, right? If it's a stable steady state, it should repeat ad infinitum. But if it's not a stable steady state, then yeah, you'll basically you'll gravitate towards that state, but you won't stay in that state for very long. So yeah, we're basically concerned with three things. We're concerned with influence functions, we're concerned with the individual dynamics, and we're also concerned with the steady states and their stability. What is the aim of the model we're building? The aim of the model we're building is, right, if a model is correct, it should be able to backtrack and reproduce a sequence of RCISS scores that has already occurred between the couple. And hopefully, if all works well, we should be able to predict future RCISS scores, repeat them over a couple of iterations, and hopefully we should be able to figure out underlying patterns in how the couple is interacting with each other. So the one key assumption we will be having in this thing is a sort of memoryless property, in the sense of, we'll assume the spouse's score only depends on their previous score and the previous score of the spouse, right? So basically, we will be assuming that, for example, WT1, T plus 1, is only a function of WT and HT, and HT plus 1 is only a function of WT plus 1 and HT. Now, you might feel that the indices are a little mixed up. They aren't. We're going to make another simplifying assumption. Our next simplifying assumption is the wife always speaks first within these conversations. Yeah, just to be clear, no stereotyping, nothing of that sort. It's only within these conversations, the 15-minute conversations we're talking about, that we assume the wife speaks first. And using that, we basically model our future scores as functions of WTHT and functions of WT plus 1 and HT. And using that, our aim now is to find F and G. To do that, we will again have to make some simplifying assumptions. One of them we already spoke about. The score will only depend on the two previous ones. We will also assume that these past two scores contribute separately and that effects are additive. We'll assume the effects are additive so that it makes our life easier. So yeah, now a person's score is regarded as the sum of two components. One on their own previous score, the individual dynamics component, and on the score of their partner's last turn of speech. Remember, the score we're referring to here is just net positive interactions minus net negative interactions at each turn of speech during that 15-minute conversation. And Yeah, we term these the uninfluenced and influenced components respectively. Uninfluenced because it doesn't relate to the other person. Influenced because it's purely dependent on your interaction with the other person. Now, first we look at the uninfluenced component, right? You consider a baseline temperament, the individual's uninfluenced steady state, what they would naturally gravitate towards if they weren't interacting with the other person. And yeah, they tend towards. Yeah, it's a natural state they would tend towards, irrespective of how their interaction with the other person is going. And we'll model it pretty simply. We'll just model it as a linear equation, right? Their individual steady state score at turn t is just going to be Ri times their previous score plus a constant Ai. Ri can be one of two things, right? It could be a decay term if it's less than one, right? Or it could be an excess term if it's greater than one. For the sake of our dynamics, right, you'll see that we'll end up, when we're solving for it, right, iteratively, we'll just end up with a sort of geometric series solution to it. And because we want the geometric series solution to converge, we'd only consider the cases where Ri is less than one. Because if Ri is greater than one, then yeah, the score will keep exploding. So there's no point even analyzing that situation. It's only when the inertia, Ri here is referred to as the inertia, right? Why is it the inertia? Because it's basically what determines how quickly or how slowly the person will move to their steady state. So our only concern is we want the inertia parameter to be less than one. That is the only way we move towards a limiting solution. Else we just won't have a limiting solution. So yeah, now again, for the influence component, we can choose one of two functions, the two-slope function or the sigmoidal. The sigmoidal function suits better for our threshold assumption, but that doesn't mean we won't be using the two-slope function. Both of them have their own purposes. And this is just a further bit of notation. IABAT is basically the influence of person's A state at turn T on person B state. To be fair, you don't need to bother too much with the notation because it starts getting very confusing once we get to the derivations and stuff. But yeah, so these are the two equations we basically have to model our scores into the future based on what's already happened. Yeah. So the first half is just the influence function. The second half is basically the linear term that models the individual dynamics. Now, what do we want to do? We want to isolate and estimate their uninfluenced behavior. Uh, we want numbers and estimates for the parameters themselves, R1, R2, A, and B, right? So what we basically do is we set the partner score to 0, right? The moment you set the partner score to 0, you'll automatically make the influence function 0. And that will allow us to do a least squares fit to determine all 4 variables, right? You look across the entire interactions at all pairs wherein at least one of the scores is 0. And the moment one of the scores is 0, you'll end up with this situation. Now, yeah, haven't found the uninfluenced steady states and inertia of each part. Yep. Yeah, so now to figure out what your influence function is, of course, because you've already have R1, R2, A, and B, you'll basically subtract the linear component that models your individual dynamics from the overall score for you to get the influence function. So you repeat this analysis for both the husband and the wife, and you can average out these influence functions over all turns T and plot them for each member. How do you validate these influence functions you basically have? You can basically simulate a 15-minute conversation between the couples from once you find out the influence functions as well. And that will allow you to both analyze underlying trends in the couple, as well as map it to historical data you already have to figure out whether it models sufficiently closely how the couple are interacting. Now we get to the actual analysis part, I guess. How many of you have done differential equations here too? You have. Okay, so if you're in year 3 and above, it should be sort of clear, but if you're in year 2 and below, because I don't think you've done null clines yet, I'll just explain it, right? So null cline is basically where a solution wherein you set your differential equation to 0, right? You pull out the parameter out of it. For example, here you basically want to solve for WT and HT, right? The scores at turn t, assuming your differential equation, whatever that differential equation is set to 0. Why does that help? So that helps basically because when you plot the null clines, the point where the null clines are intersecting is a steady state. It's a point where the rate of change of both the differential equation components is 0. So automatically you're ending up with a stable point. So yeah. Yeah. So that's the reason we're interested in the null clines. They'll basically help you figure out relatively easily using just pure algebra what the steady states and are within the system. The interesting stuff comes from after that. You basically want to figure out what the stability of these steady states is, because that will tell you whether the interaction comes to a close, whether the conflict is resolved within that 15 minutes or within that time span, or whether you'll end up with some unstable steady state wherein you go into it for a relatively short period of time, you come out of it, and yeah. So this is just a bit of algebra from our previous set of equations. You'll basically end up with these as your null clines. So you basically want to plot both of these, right? The W of H of t and H of W of t. And you want to solve for them simultaneously to analyze the and you would basically get the point which is a steady state. Now you would want to analyze the stability of that steady state. How would you do that? So this is an example of the null clines plotted in the phase plane. The points where they're interacting are basically steady states within the thing. It's basically, if it's a stable point like this, once you hit this point, the conversation just stays there. It's basically the conflict is resolved. It doesn't take into consideration what emotion the conflict is resolved at. Again, because if you see here, both of them have a net negative effect, but the conflict is resolved. So they're probably still bitter after the conflict has been resolved. This one, you'll see that the husband has had a positive resolution to the conflict, but the wife is still in the negative domain. So she still hasn't had a complete true resolution. This is again stable. Once it gets here, there's no going out of it. But if you look at the white dots, those are places where the resolution isn't stable. So the conflict is probably going to carry on even after that. So yeah, it's something that cannot be constrained to the 15-minute conversation or to the dynamics of our conversation. Another example of null clines, similar logic. If you see a darkened dot, it basically means it's a stable point. If you see a light one, it basically means it's not a stable steady state. So even if you get to that state, you're bound to leave it at some point. So the next couple of slides is basically just going to be, yeah, it's if you take math bio in year 3, this is pretty much what you'll be doing at every turn of the step. But yeah, so we're basically just going to examine the stability of the steady states, WS and HS. We're assuming that there's a small function that we add to WS and HS because both of them are stable, and WT and HFT will keep hovering around them. We use Taylor's expansion, and we only keep the linear terms. I've skipped a whole lot of steps within the derivations and stuff because I didn't want to clutter it with too much of mathematics. If any of you are interested, I can show a bit more of the working, or you're always free to refer to the textbook. The textbook has everything in perfect detail, so yeah. Now, so basically what happens is, right, why are we using the Taylor expansion? The reason we use the Taylor expansion is because we want this term. Why do we want that term? Because when we started off, right, our influence function was basically just between the husband and the wife and how much either of them affect the other during the span of the conversation. What we're actually interested in is how this influence, the gradient of the influence function itself. We'll get back to it. The reason why we're interested in the gradient of the influence function. The key reason for us being interested is basically when we do the gradient of the influence function, we'll basically end up with a very nice method for us to estimate some of our parameters and stuff. We'll get to it soon. So these are the two equations you'll end up with on basically doing a Taylor expansion for Wt plus 1 and Ht plus 1. So you'll end up with this equation here, the bottom one, and the first equation on this slide. So what you'll basically do is you'll take both those equations and you'll set up a linear system of differential equations with the stability matrix is basically the matrix that is used to construct your linear differential equations. This is the stability matrix. Why do we care about the stability matrix? Is because the eigenvalues of the stability matrix are going to give all the information we need to figure out whether our steady states, which the conversation is tending towards, will be stable or unstable. So again, a bit of oversimplification. If you want proofs for any of these facts and stuff, you could go through the year 2 differential equations notes, or you could pick up pretty much any analysis differential equations textbook and it should be there. Again, I'm skipping a whole lot of algebra and stuff because I do not want to bore any of you. We basically take the characteristic polynomial of f. We calculate what the two eigenvalues would be. It's this horrible looking expression. And from that, we basically derive our conditions for stability using the fact that the absolute value of the eigenvalues must both be less than 1 in this specific scenario. The reason it has to be less than 1 is because we've scaled our differential equations to accommodate that specific fact. And the condition for stability is, the product of the two gradients has to be less than 1 minus R1 and 1 minus R2. Again, drawing your attention to R1 and R2. R1 and R2 are your emotional inertia. They're your individual dynamics of how likely you are to stay in a specific emotional state that you were put in for a prolonged period of time. Now, that basically allows us to draw some conclusions. What are the conclusions? The two conclusions are, right, if you have high emotional inertia or you have a very steep influence function, right, you're highly likely to influence your spouse or your partner. They are, in fact, very destabilizing from a steady state. It agrees with intuitive expectations in psychology. Marital psychology generally tends to say that things that are, if you have a more balanced approach towards influencing each other and conflict resolution in general, it's basically considered to be a good sign. But this is where we're dealing with extremes. Extreme inertia, as well as very large influence functions, are detrimental towards a steady state, which can be achieved when there's conflict resolution. Why? I'm hoping it should be pretty obvious because you can see that if both these gradients are very large, then of course that means the functions themselves are very steep. So you're bound to have that they would be greater than 1 minus R1 and 1 minus R2. On the other hand, if R1 and R2 are very large, if the emotional inertia of the people in of the two partners in the couple are very large, then that's bound to be much less than the product of our gradients. So both ways, the inequality would not be satisfied, and you would end up with an unstable steady state, which isn't ideal. Now, here's why you care about the, this can also be studied by obtaining the gradients of the null lines, because if the product of the gradients of the null lines is less than 1, we obtain stability in the steady state. Why is that? So I don't think I've included it in the slides, but there is a relation between the derivative of the influence functions and the gradient between the scores of the husband and the wife. There's the dh over dw and dw over dh, both of them are encoded within this. So, which you can obtain from the null lines. So basically studying the gradients of the null lines gives you this. For the gradients of the null lines, the condition simplifies quite a bit. You basically have to go through a bunch of algebra again on the previous equation. If the product of the gradients of the null lines is less than 1, you obtain stability in the steady state. So, yeah. Now, final notes on the mathematical model itself before we go to what conclusions we can draw out of it. It allows us to do multiple things. It allows us to analyze underlying trends in a marriage by simulating RCISS scores over multiple conversations and then fitting them with the marriage typology to build a theory of marriage. We're basically trying to typecast people into what sort of a couple they are. We can also use our model to figure out steady states, conflict resolutions, and whether these are temporary or true steady states, right? And we've also successfully incorporated individual dynamics with influence, allowing us to use influence functions to study marital interaction. Conclusions. There's a couple of slides of conclusions, but it should be pretty quick. Influence functions. So all the algebra, all the calculus, everything we've done so far gives us individual influence functions. The reason the individual influence functions matter, not marry, is the reason we care about them is because they tell us a lot about how the couple would be interacting within their marriage, right? We typecast the influence functions into 3 types: volatile, validating, and avoiding. Volatile is basically when it tends to swing between extremes. Validating is a more gentle slope. And avoiding is basically when the gradient is almost at 0. So they neither tend to influence the other person nor, they usually don't tend to influence the other person much. So, yeah. How do you figure out which of these 3 it is? Again, just take the gradient of your RCISS curves and stuff. And if it's high, it's volatile. If it's medium, if it's relatively low, then it's validating. If it's very close to 0, then it's avoiding. Yeah, so now from this, we basically derive something known as the mismatch theory, which basically tells us that if the 2 types of couples that usually head for divorce, the avoider and, my bad. What was it? The hostile and hostile detached. Yes, thank you. So the hostile and hostile detached tends to have a mismatch between 2 people, right? So the key thing to observe here is validating is fine, but because volatile and avoiding are 2 extremes of the spectrum, having both of them in the same marriage makes it very hard for the marriage to succeed, for the simple reason that you almost would never attain a steady state, and you'll basically always have a lack of conflict resolution, ultimately leading to divorce. The mismatch theory. So basically, the mismatch theory tells us that typically the reason for a marriage to fail is because 2 people come together and they try to create one of the 3 stable types, either a volatile, an avoiding, or a validating marriage, but they fail at it for the simple reason that one of them is volatile and the other is avoiding, or basically there is a certain amount of mismatch between them that we can measure mathematically that leads to, it leads to the dissolution of the marriage because it just doesn't work. Now, this fits with something known as the demand and withdraw pattern, a bit more of psychology. The demand and withdraw pattern is when, during a conflict, one person wishes to pursue the conflict and actually speak about it and try to resolve it, but the other person, being avoidant, does not want to pursue the conflict any further and just wants to leave it as it is, right? If you usually have this sort of a mismatch over prolonged periods or due to multiple reasons, you're bound to have what people would call an unhappy marriage, because one of the persons does not have the requirements for the conflict resolved, neither does the other person because they don't want to engage in any conflict at all. So again, this is empirically an observation, right? Again, no typecasting and no stereotyping. It has been observed that wives tend to be the demanders while husbands tend to be the withdrawers. A demander is someone who wants to engage in the conflict, while a withdrawer is someone who does not want to engage in the conflict, leading to higher criticism amongst wives, and stonewalling amongst husbands. Husbands tend to not speak about anything and they just try to build a stone wall and they do not care about the conflict or what's happening. But the wives tend to try to resolve the conflict, which leads to higher criticism for them. So yeah, again, based on the paper by Cook and co-authors in 1995, the unstable groups are differing in interaction styles, which is again reflective of differences in preferred style of marital adaptation. Um, Again, as with most of the things we do in mathematical biology, this analysis is incomplete without the parameters of inertia and influenced and uninfluenced states, which adds more complexity to the model, making it harder to analyze. So we've simplified the model quite a bit to draw our conclusions regarding the mismatch theory and influence functions and stuff. Divorce prediction. So from our model and from the paper by Gottman and Levinson overall, the two main things that are predictors of divorce is the wife's emotional inertia, which relates to the regulated, non-regulated typology, as well as both the husband's and wife's steady states, right? So these are the two key predictors. Very high levels of emotional inertia will basically lead to unstable steady states, so which means no conflict resolution and hence a higher chance of divorcing over prolonged periods of time. And if both of them have very low steady states, right, they would tend to have very low satisfaction in the marriage, and so they would again head for divorce. Positive effects. Let's end on a little bit more of a happy note. Wives with more emotional inertia made fewer of the Duchin smiles we were speaking about. Again, to recall, Duchin smiles are basically when your lips move way up on your face and you use the muscles near your eye as well. So the smile uses almost every single facial muscle. So it's considered to be a very happy interaction. Um, so yeah, wives with more emotional inertia had fewer Duchin smiles than wives with less emotional inertia. And husband and wife steady states were related to fewer Duchin smiles, but only for wives, right? And again, going back to RCISS scores, husbands with higher steady states laughed more, while wives laughed more if either them or their husband had his highest steady state. So the highest steady state is basically just referring to how far along the positive axis or the positive side you're interacting to resolve your conflicts and stuff. Now, the actual conclusion. The model is highly simplified, as we've seen. It is a very simplified approach to a complex social phenomenon, right? We can improve the model through a variety of things. You could, for example, we didn't consider parenthood, which is a very big it's a very big thing to consider because adding another person would basically make us have three differential equations, and three differential equations is the requirement to lead to chaos. So yeah, you basically would have a much harder time modeling it, but you could draw much more interesting conclusions from that. And another thing you could add, for example, to the videographic interview is their heart rates. The heart rates might give you a better idea of whether the conflict is actually being resolved well or, yeah, whether it's just dead in the water. Now, this approach of quantitatively describing qualitative phenomenon is relatively new. Even this, the actual key parts have been updated as recent as 2005 and stuff. So it's still relatively new, 20 years at this point. But it is exciting because, again, you're free to check out Gottman's website and stuff. He writes a bunch of interesting blog posts and stuff. He has been incorporating conclusions from this mathematical model and stuff in his clinical marital therapy with encouraging results. So that's it.
For this theory.
Huh?
I feel like it's relevant whether dogs are gay.
Oh yeah, he is. He's happily married. He's happily married. That's the first thing I checked when I started researching the topic as well. So yeah.